With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given that calculate the pH of the following mixture given that Ka of CH3COOH is 2 into 10 to the power minus 5, right? Now it is given that 50 ml of 0.10 molar NaOH and 50 ml of 0.10 molar HCl. In the first case it is the mixture of strong acid, mixture of strong, you can say base and strong acid. So in case of mixture of strong acid and strong base, you know what is important. You need to calculate the number of milliequivalents of base and acid. So of base, if you want to calculate, then it is of NaOH, then that will be equals to, you know very well that normality into volume in milliliters. So what is normality given? It is 0.10. Now we know that normality can also be written as molarity into n factor, right? So this formula can also be written as molarity into n factor into volume in milliliters. So what is the molarity given? The molarity given to us is 0.10 molar and the n factor for NaOH is 1. You know very well that it dissociates to give only 1 OH minus ions. So n factor is 1. Now further, what is the volume given? It is given 50 ml. So finally this value will come out to be how much? You can see this value will be 50 into by 100. So this will be 5, right? So it will come out to be 5, right? Now if you calculate the number of milliequivalents of acid, number of milliequivalents of acid, which is given HCl, right? Again it will be same, you can say molarity into n factor into volume in milliliter. Now we know very well that molarity is given to us as 0.10 again. N factor for HCl is 1 only because it gives only 1 H plus ion on dissociation, and the volume is given 50. So again the same thing you will get here also 5. So what is important? You can see very well that the number of milliequivalents of acid and number of equivalents of base are equal. So when milliequivalents of acid equals to milliequivalents of base, in such cases when milliequivalents of acid is equals to milliequivalents of base, then what you are going to say that pH of the solution, pH of solution is 7, right? Because it is a neutral solution, because number of milliequivalents of acid and number of milliequivalents of base are equal. It means that the solution is neutral and its pH will be 7. So the first answer will be that pH is equals to 7. Now let's see the second one. In the second one it is given 50 ml of 0.10 molar NaOH and 50 ml of 0.10 molar CH3COOH. So now let's see the reaction for the second one, right? So for the second one, what is the reaction? NaOH plus CH3COOH is going to give you CH3COONA plus H2O. Now if you see what was the value of the concentration as well as the volume given to us. So it is 50 ml of 0.1 molar. So let's write down the number of millimoles. It will be 50 into 0.10, right? And for CH3COH also it is 50 ml into, so the number of millimoles, we all know millimoles is what? Molarity into volume in milliliter. This will be 0 at T is equals to 0. So let's say at time T is equals to equilibrium, this will be 5 millimoles. This will be 5 millimoles. Let's say not at equilibrium, but still at T is equal to 0 I am writing. After multiplying it will be 5 millimoles and 0 and 0. Now if you discuss it at equilibrium, then what will happen? This will become 0 because 5 millimoles will react with 5 millimoles. So it will become 0 and here it will be left 5, right? So if you want to write down the concentration of CH3COONA then the concentration will be millimoles. You can say whatever is the millimoles, that is divided by the volume. So if you want to write down the concentration, it will be 5 by 100, but this concentration will be in millimoles and volume will be in milliliter, right? So it's okay, millimoles by milliliter. Now this is the concentration, because volume, this is the total volume 50 plus 50, right? Total volume is 50 plus 50, and this is the millimoles. Now since you have what, you have salt in the solution, and what it is salt of weak acid and strong base. It is salt of weak acid and strong base, right? So this is now going to form salt hydrolysis. Now in case of salt hydrolysis, you know that salt of weak acid and strong base, the pH is given by 7 minus half pKa plus half log C, where C is the concentration of this salt, right? So let's calculate the pH. pH will be 7 minus half. What is pKa? pKa value is already given to us. The Ka value is given to us as 2 into 10 to the power minus 5. So pKa will be what? 5 minus log 2 plus half into log C. What is C? C we have taken. What is the concentration? It is 5 by 100 or 0.05, right? So if you calculate this value from here, you will get the value of pH is equals to 4. Exactly, you will get the value of pH is equals to 4, and this is only the required answer for the second part, that the pH of the solution will be 4. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.